Okay, students, so this is example 1 for your effect of bed level. Okay, you are given a rectangular channel 5 meter wide and 1.75 meter deep. Okay, channel width 5 meter and the actual channel depth is 1.75 meter. Discharge water at a rate of 8.5 meter per second. So that is Q. The normal depth of flow. Okay, the normal depth of flow is your Y1 that represent 1.2 meter. Okay, para saya lah. Okay, determine the depth of flow downstream of a section in which the bed rises by 0.2 meter over a distance of 2 meter. Okay, if you are not given this figure, so you have to sketch or you have to translate the given information into sketches. Okay, so for this case, this is effect of bed level, so you have to memorize that there must be a parameter at the location 1 that represent your upstream part, and the condition for location 2 where the location of the wheel. Okay, so in this case the bed rise by 0.2 meter. Okay, so you may assume that at location 2 there will be a hump with delta z 0.2 meter over the distance of 2 meter. Okay, so delta z 0.2 meter sepanjang 2 meter. Okay, so kita boleh consider that the delta z is very minimum in order to create the critical flow, sebab sangat kecil lah perubahan bed level tu. Okay, so you may consider the first condition. Okay, sebab you nak dapatkan depth of flow downstream with respect to Y2. Okay, you may start the analysis based on considering for type 1 where the flow will be non-critical condition. So if you look back at this figure, okay, so type 1, type 2 or type 3, so the flow pattern will be as a type 1 condition. Okay, for type 1 condition, E at location 1 is minus with E2 equal to delta Z or the Weir height. Okay, so the analysis will be based on E1 minus E2 is equal to delta Z, knowing that delta Z here, Weir height is 0.2 meter, and E1 represent Y1 plus B1 squared over 2G. So basically, you can calculate this value E1 because you are given Q. Q can be Q is equal to AV, right? So then you can calculate the V1 with respect to Q over BY at location 1. Okay, so you get the delta Z value, you get the E1 value. So E2, if you take out the equation, Y2 plus V2 squared over 2G. So V2 is actually represent Q over B Y2. So Y2 is your unknown. Okay, so if you rearrange your equation, E1 minus E2 is equal to delta Z 1.302, that represents your E1, Y2 in the term of E2 in the term of Y2, and this is your delta Z. Okay, so you may use your calculator to solve directly. The flow depth at the location 2 is 0.93 meter. Okay, so you can list out the summary, the location at the upstream, location 1, and the parameter at the location 2, which is above the hump. Okay, right. So that is for your case 1 or type 1. Okay, let's say, okay, I ask you, what is the minimum Weir height to produce critical flow? Okay, so this question asks you to calculate or to determine the delta Z critical. So delta Z critical can be calculated using type 2 condition where you have delta Z critical parameter here. So by considering location 2 now become the critical flow where Y2 is equal to YC. Okay, so there is no changes at the upstream part. So based on the condition 2 of type 2, the equation will be specific energy at the upstream minus specific energy at the location 2, which is your E minimum, is equal to delta Z critical. So E1 can be extracted from the previous calculation. E minimum with respect to 3 over 2 of DC or YC. So how to get YC? Because this is rectangular channel, obviously you can calculate directly from flow rate per unit width squared over G square root 3. Okay? Square root 1 over 3. Okay? So YC is become 0.665 meter. Then if you recheck, the previous Y2 is 0.9. So logic lah. Okay? So you can simply calculate your delta Z critical based on 1.302 minus 0.998. Then this is your delta Z critical. And if you recheck, your delta Z critical 0.304 is of course must be higher than your previous Weir height in the type 1 condition. Because we know that at 0, Weir height 0.2 meter, that will not create critical flow. When you increase delta Z, that will create critical flow. Okay, so what if? Okay, what if the Weir height is increased to 0.4 meter? Determine the flow depth at the upstream. So now, previously you already calculated that delta Z critical, delta Z Weir height that create critical flow is equal to 0.304. And the third case, when you have delta Z which is 0.4 meter higher than delta Z critical value. Okay, so this represents the type 3 condition where location 2 remain as critical flow, but then the upstream part will become the flow that at the upstream will be higher from the original Y1. Okay, so for type 3 condition, the equation will be new specific energy at the upstream minus the specific energy minimum is equal to delta Z 0.4. Okay, knowing that location 2 remain as critical flow, that will give you specific energy minimum. And how to get E specific energy new at location 1. Okay, so considering that E new at location 1 is actually your new flow depth at location 1 plus with Q squared over 2G Y1 new at the upstream. Okay, so how you get this equation? This is actually same with the concept of V squared over V is equal to Q over A. Okay, you can simplify the equation in terms of flow rate per unit width, or you may simplify the equation in the term of V Q over By. Okay. Okay, so I noted here how you get this flow rate per unit width, because originally is V squared over 2G, right? So this is Q squared over By1. Q over B is actually flow rate per unit width, then they can be simplified in terms of Q kecil. Okay, so you will get E1 is actually your for E new at the upstream part, E1 will be unknown in the term of Y1. Okay, so if you rearrange the equation, okay, with respect to Y1 prime plus Q squared over 2GY1 squared minus E minimum, which is 0.998, is equal to 0.4. Then you simplify, you akan dapat 1.8. 1.398 ni. Okay, so based on this equation, you can solve directly. Your y1 prime is actually 1.32 meter, and you have to make sure the new y1 in the type 3 condition must be larger than y1 previous, which is 1.2 meter. Okay, so this is how you're going to self-check your calculation. Okay, so for the exercise, I would like you to try this question December 2015, and I already give you hint here in order you to solve the uh, exercise. Okay, so this exercise must be submitted before your Hari Raya. Okay, and you may solve it today sebenarnya. Okay, sekejap je ni. Okay, so this is the answers. Okay, you may download these notes from Iron Photon. Okay, due to that, thank you.